Dear students, in this video we are going to discuss microprocessor and microcontroller. Today's contents: microprocessor introduction, evaluation of microprocessor and components of microprocessor. So, introduction to microcontroller. Next, comparison of microprocessor and microcontroller. So now let us see introduction to microprocessor. Okay, so all we know microprocessor is a brain of a computer. Okay, so microprocessor we also call it as a CPU. Generally we call it as a CPU. CPU is nothing but central processing unit. So this is the main part of the computer which performs all the operations. Okay, so the microprocessor is nothing but it is the brain of the microcomputer, because the everything is done by the processor itself. Just like a human brain, if suppose our brain is dead, so we can't do anything, even we can't lift the hand also. Okay, so because the brain is sending every information to all other parts of the body. So in the same way, processor we call it as the brain of the computer. Okay, so the processor, CPU, all are same, just we are using different names. Okay, so this is a simple chip. Okay, simple chip that is present inside the computer, means inside the motherboard. So that single chip is called as a microprocessor. So micro means small. Okay, so it is a small processor, but it does lot of operation. Means it is a brain of microcomputer, just doing everything, whatever the processing, whatever the controlling, whatever the executing, everything is done by this chip. Okay, so this chip is present inside the this chip is present on the motherboard. Okay, so a computer consisting of a motherboard. Inside the motherboard we are having the small chip that is called a microprocessor. Okay, so it is a single chip, right, which is capable of processing data. Okay, so whatever speaking now, whatever the explaining to you, it is sent by my processor, that is the brain. Okay, just like that, a microprocessor is performing all the operations. It is a single chip which is capable of processing data. Okay, and it controls the all components in the computer. So in a computer you are having so many components like monitor, input output devices, memory device, USB ports, disk, everything, every different components present in the computer are connected externally to the computer. Those are controlled by the microprocessor. Okay, so my brain is a microprocessor. So my processor is controlling every part of the body, like hands, legs, ears, nose, smelling the things, tasting the things, everything is controlling my brain. Okay, so my brain is sending the signals to every part of the body. So if you want to jump, my brain is sending signals to legs to jump, just like microprocessor. Okay, so sending controls to all parts of the body. In the same way, microprocessor controls all components in the computer. All components means memory, IO device, external device, everything is controlled by microprocessor. Okay, and one more important point is it executes the sequence of instructions. Okay, so whatever the data the user is giving, that will be executed one by one after another. That is in the form of, first we are fetching the instruction, after that we are decoding the instruction, after that executing the instruction. So the microprocessor fetches the instruction, means taking the data. Okay, taking the instruction from other devices, other components of a computer. Okay, so it fetches the instruction. After that it decodes. Decoding means whatever we are giving the information, just like English type language, means C++, Java, whatever you are giving the language, it is like English letters. Okay, so the processor cannot understand ABC format English letters. Okay, so the processor will understand only binary information, that is in the form of zeros and ones. So the language should be it's a machine language. Okay, so whatever we are typing the information, that is the high level language. The high level language that should be converted into first assembly language. After that it converts into machine language. So this machine language is understood by the processor. So machine language is in the form of zeros and ones. So that the microprocessor first fetches the instruction, and the instruction will be decoded, means zeros and ones, and after that it executes the instruction, means doing the operations. Okay, executing means performing the operation. Okay, next one. So this is the simple Intel Pentium 4 micro processor. Okay, so next we will see the evaluation of microprocessor. Okay, so the first one is the Intel 4004, that was developed in 1971. Okay, so the first microprocessor, that is the Intel 4004, was a 4-bit microprocessor with a clock speed of 740 kilohertz. It is having around 2300 transistors. Okay, and the memory is 4 kilobytes memory. Okay, and it was primarily used in calculators. Okay, simple devices, calculators and simple devices. Okay, so the next one is Intel 8008, that was developed by in 1972. Okay, so it is a 8-bit version of 4004. Okay, and the clock speed, so 500 kilohertz to 800 kilohertz. It has around 3500 transistors, and it will address 60 kilobytes of memory. Okay, next one Intel 8080, 1973 it was developed. It is an 8-bit microprocessor, and the main memory is of 64 kilobytes. Okay, and the transistors were used in this Intel 8080 is 6000 transistors were used. And one drawbacks in this 8080 is it needs 3 power supply, minus 5 volts, plus 5 volts, and plus 12 volts. Okay, so next is a 16-bit era, that is Intel 8086 and 8088, developed in 1978 and 79 respectively. These are the 16-bit microprocessor. Okay, the clock speeds up to 10 megahertz, and 29,000 transistors were used, and the memory capacity is 1 megabyte. Okay, and next one 1982 1836 was developed. It is a 16-bit microprocessor, that is the upgraded version of 8086. The main memory is of 1 megabyte main memory. Okay, so next 1983 Intel developed 80286. It is of 16-bit high performance microprocessor, where it introduced the protection mode and enhancing multitasking and memory management. The memory is 16 megabytes. Okay, next 80386, it is a 32-bit processor with clock speeds of 33 megahertz, and it supports 4 gigabyte of memory. Okay, and next one 80486, it is also a 32-bit processor. Next Pentium processors came, and next Intel processor came. Okay, the Pentium series processor were significantly that is it supports that is super scalar architecture. Okay, so and allowed multiple instruction per clock cycle. Okay, next AMD process came, Intel cores. Okay, so the Intel core series, Intel the new micro architectures were introduced, and significantly improving the performance and power efficiency. Okay, next AMD Ryzen also came. Okay, so next one, the microprocessor. What are the components in the microprocessor, we will see. So microprocessor mainly consisting of three components. Those are arithmetic logic unit, control unit, and register. Okay, so there is no RAM and ROM and IO ports inside the microprocessor. So if you want to connect, we can connect externally, the random access memory, read-only memory, and IO ports. Okay, so microprocessor, it consists of ALU, control unit, register. So all you know, ALU is nothing but arithmetic and logical unit. Okay, so it performs arithmetic operations as well as logical operations on the specified data. So the data is taken from the input device or memory. Okay, next one, control unit. Control unit is it controls the instruction and flow of the data within the computers. Next component is register. So register is nothing but it is used for temporary storage of data. Okay, so this is the 8086 block diagram. So the microprocessor, and we are connecting external devices, that is input output device, memory. Okay, because microcontroller doesn't have inbuilt memory, so we need to connect externally. Okay, next one, these are the generations. Okay, first to fifth generation. The first generation is 1946 to 1959. So these computers were used vacuum tubes for the circuitry, and here the magnetic drums for memory we are used. Okay, so in this generation, first generation, they were extremely large, occupying the entire room. Okay, so high power consumption and generated lot of heat. Okay, so the programming was done in machine language in this generation. Okay, so next generation, that is second generation. The second generation replaced the vacuum tubes with the transistors, so which was smaller, faster, cheaper, and more reliable. Okay, in this generation, the computers became smaller and more efficient. So they used magnetic core memory and introduced high level programming language like COBOL and Fortran, and reduce the heat production and compared to the first generation computers. Okay, so the example for this second generation is IBM 7090, one of the early computers using transistors. Okay, next third generation, that is that was 1965 to 71. So the integrated circuits were developed, ICs, which combine multiple transistors on a single chip. So that were used in third generation. Okay, so significantly reduced in size, cost, heat generation. Okay, so here in this generation, the operating systems were introduced that allowed computers to run multiple applications. Okay, and next one, fourth generation, the development of microprocessor marked this generation only. Okay, so all computer components were integrated on a single chip. Okay, so personal computers became widely available in this generation. Okay, so semiconductor memory is replaced with the magnetic core memory. Okay, and the graphical user interface. So the rise of user-friendly softwares are developed in this generation only. And the example in the fourth generation is first Apple and IBM PC were the products of the 4th generation. And the next one, 5th generation, that is 1980 to present. The 5th generation focus on advancement in artificial intelligence and the use of VLSI technology, very large scale integration technology, so which allows millions of transistors on a single chip. Okay, so the computers are now incredible powerful and portable, and internet facilities are also available in this generation. Okay, so major improvement in areas that is AI, artificial intelligence, next natural language processing and parallel processing, and device like laptops, smartphones, cloud computing systems are the part of this 5th generation. Okay, so next one, in introduction to microcontroller. Previously it's a microprocessor. Now we will see the microcontroller. So microcontroller is nothing but it is a compact integrated circuit designed to perform a specific task, so within the embedded systems. Okay, so it includes read-only memory, that it includes CPU, read-only memory, random access memory for storage, and input-output peripherals on a single chip. Okay, so microcontrollers are used in a various application where low power consumption, compactness, and real-time control are important. The microcontrollers are used. Okay, so the components in this micro controllers, that is ALU, registers, control unit. So this is together we call it as a microprocessor. Next, RAM. RAM is nothing but temporary data storage for during the operation. ROM is for storing the programs and data even when the power is off. And IO ports are used for communication with other devices such as sensors, actuators, and other digital components. Next, timers and counters to manage the timing related functions. Next, communication interface such as UART, Universal Asynchronous Receive Transmit, SPI, I2C for communication with other devices, ADC, analog to digital converters. So all these are embedded into the single chip, that is called as a microcontroller. Okay, so nowadays, today there is no electronic gadget on the earth which is designed without a microcontroller. Okay, so these are the some personal information products, mobile phones, calculators, smartwatches, pages, sound records. Okay, sound recorder, laptop components, keyboard, mouse. Okay, pen drives. So all these are the some personal information products. Next, some applications, that is home appliances, that is smart TV. Modern smart TVs are equipped with microcontrollers to manage such tasks such as user interface, internet connectivity, video streaming, and interacting with other smart devices. Okay, next one, microwave oven. Okay, microcontrollers are used in microwave ovens, so control cooking times, power settings. And the next one, refrigerator. Advanced refrigerators use these microcontrollers to regulate temperature, manage cooling cycles. Okay, so next one, washing machines. Washing machines nowadays use a microcontroller to automatic wash cycles, control the water level, and that manage motor speed based on the type of fabric or load size. Okay, next, industrial equipments. Okay, so robotic welding system in industries, microcontrollers, that is robotic arms for precision welding task, ensures accuracy, safety, and speed in manufacturing processes. Next, automobile assembly lines, we are using this microcontrollers to manage tasks such as assembling car parts, okay, painting and quality control. Next, bottling and packaging. Next, food processing machines. Okay, so these are the some applications of micro controllers. Okay, so so to design any controlling or automatic system, first we should know what type of controllers are used, what is the architecture, advantages, disadvantages, way to reduce the production cost and reliability. Okay, so next we will see the differences between the microprocessor and microcontroller. Okay, so already you know microprocessor is nothing but it is a electronic component that functions as a CPU. Okay, so a single chip consisting of ALU, okay, registers, okay, uh, so without any RAM, ROM, IO ports. Okay, so it serves as the central processing part of the computer or other complex systems by performing general purpose computations. Okay, so here there is no RAM, ROM, IO ports present inside the microprocessor. Okay, so the RAM, random access memory, read only memory, IO ports and other peripheral devices are connected externally. This external addition offers flexibility to connect various peripherals, so making it suitable for complex systems where multiple devices are interfaced. Next, cost and coming to cost and application. Microprocessors high cost and typically support multitasking. Multitasking means they can handle various processes simultaneously. So due to their ability to manage heavy computational tasks, microprocessors are used in complex systems such as computers and laptops. Okay, coming to the power consumption, microprocessor consumes high power, so as they need to manage expensive computations, support multitasking and deals with multiple external devices. Okay, so these are used in computers and laptops. Okay, so the examples for this microprocessor is Intel 404. Nowadays we are using i3, i5, i7 and i9 processor. Next one, microcontroller. So these are the compact integrated circuit designed to perform a specific application, right, specific application. Okay, so within an embedded system, so it includes processor, memory, peripherals, all are integrated on a single chip. Next, coming to cost and specific task, that is application. So microcontrollers are low cost device and are optimized to perform specific task rather than general purpose computation. Okay, um, right. Next one, power consumption. Microcontrollers are designed for low power consumption. Okay, so which makes them ideal for the use in embedded systems that needs to operate continuously on a minimal power, such as ACs are there, air conditioners, washing machines are there at home we are using, and other home appliances. Okay, so the microcontrollers are used widely in consumer electronics, automobiles, industry application. Examples, controlling the temperatures in air conditioning and washing machine, monitoring sensors and IO devices. Okay, so the examples for this microcontroller is 8051 microcontroller, 8052 microcontroller and AVRs. These microcontrollers are used in various control application and smart embedded systems. Okay, thank you everyone.